Here we go with example 2 of inequalities. Let's take a look at an application of the concept. So, we have a business called Cow's Cars, and their revenue expression is given by this. It depends on how many vehicles they sell. That's the variable this time, is vehicles, V. So revenue is calculated by this, cost by this. So when you want to make a profit, revenue is the money that you bring in, correct? All right. And cost is the money that you spend. So if you're going to make a profit, wouldn't you have to make more money than you spend? In other words, doesn't the revenue need to be greater than the cost? That's what a profit is, to make more money than you spend. So if you apply that general idea to this specific question, let's put the revenue expression over here on the left. See, they calculate their revenue based on how many vehicles they sell according to that expression. That's the revenue expression. And we want that to be greater than the cost, which is given by that other expression, 3v squared plus 21v plus 1300. All right, so what values of v give us the relationship where the revenue is greater than the cost? So there you go, that's an inequality, and of course the desired outcome is greater. That's the relationship we want. All right, now you might say to yourselves, okay, we're not looking for equal here. You're right, we don't want them to be equal. But we're still going to solve the equation anyway, and we'll talk about why we do that. Even though it's not the ultimate goal, we still want to bring this over here and discover the values of v for which the revenue and the cost are equal. All right? Now, like I said, we don't really want that ultimately, but it's a means to an end, as we'll discuss. And again, I'm very sorry for squeezing this all in. I only have so much space. But when we get to this juncture, this should be a flashback, because once we do the equation, it should be... We then, at this point, identify the equation that we're dealing with, and this one, because of the squared, is quadratic. So I would invite you to go back and look at the examples that we did before spring break involving quadratic equations. It was assignment number 11. So I will again warn you that I will be doing this part of the process pretty quickly. Feel free at any time to pause the video and catch up with me if you want. But I would be of the opinion that since there are V's all over the place, it would make sense to get everything on one side. This was called standard form. All right, let's make it equal 0. This was assignment 11. Go back and look at your quadratic equations flow chart. I have it linked. It takes me forever to get it up here. Take a look at it. You might remember at this point, we can either do the quadratic formula, or if you're like me, you hope that it'll factor. And again, in the interest of keeping things moving, it turns out that v minus 325 and v minus 4 is how that would factor. And the factoring, I'll remind you, that's assignment 5. So there's all kinds of flashbacks going on here. And then when we set each of these individual expressions equal to 0, I want to remind you that's called the zero product principle. All right, so you set each of these factors equal to 0 and solve them individually, which is pretty easy, because all you got to do is add that number over here, add that number. Again, treat it as two separate equations. And so v would equal 325, and v would also equal 4. I have to acknowledge to you there's a lot of oversimplification in terms of real life, but the general logic is solid. So we have two values of v for which the revenue and cost are actually equal to each other. Now let's talk about what that would mean in a business. If the revenue and the cost are exactly equal, what happened in terms of business terminology? Right, we broke even. And that's the idea. These are break-even points. Okay, so in the general, this is what we're kind of doing. I'm out of my lane a little bit, but in the world of business, I think we're doing what they call profit analysis. And the point would be, before you can make a profit, you have to break even. So going to our number line, doing the oh, by the way, division by zero, sorry, let's make sure to check for that. There's no fractions. So this time, we don't need to worry about that second kind of critical value. There are no fractions in the question. So division by zero is only a potential problem if there's division in the question. And division will typically manifest itself as a fraction bar. There's no fractions here. So we're going to put these numbers on a number line. Now, it's important, even though the 325 is here and the 4 is there, on a number line, wouldn't 4 be a smaller number than 325? So make sure you put them on there the way they would appear. And this number line is actually V, right? How many vehicles are we going to sell? The variable that's in the question. But as mentioned earlier, we don't really want to break even. The point is, we don't want revenue and cost to be equal. There's no equal to here. And we did not put an equal there for a reason. So the point is, if you're a number that gives us the equal to relationship in this question, we don't really want you. You don't work. So visually, I don't think there's a better visual than an open circle to show that. Hollow. I don't want to sell 4 vehicles. If I do, I'm going to break even. Same thing for 325. We don't want that. So, you know, there's again that discussion of include versus exclude. And visually on a number line, exclusion to me makes sense. Hollow, it doesn't work. All right, so at this point in time, we look at these 3 pieces of the number line and we test a number in each one. So once again, in this example, our first interval contains the number 0. I would always suggest that when you get to the neighborhood where 0 lives, that's going to be the easiest number to plug in. It makes the math as simple as possible. Now, this is probably maybe not fair on my part, but I'm going to do some mental arithmetic on this part. If you put 0 here and 0 here, that's all going to be 0. So the left-hand side is 0. What's the interpretation? If we sell 0 vehicles, our revenue will be 0. On the other side of it, if we put a 0 here and a 0 here, those will become 0. And we've got the plus 1,300 on the other side. So again, the idea there would be that if we sell 0 vehicles, our cost would be 1,300. And you'll notice, and that was, I think, very conducive to mental arithmetic, but you'll notice that the revenue is less than the cost, and we don't want that. If you make less money than you spend, you're going to lose money. You're not going to make a profit. That's the whole point, right? So if it's less than, you're like, no, I want it to be greater than. We want revenue to be more than cost. We want more. We want more in this case. And that didn't work. So, no good. So then we pick a number in here. Now, my suggestion would be 10, because 10 lives in there. It represents all the numbers between 4 and 325, and 10 is conducive to relatively simple math, just like 0. So, again, this might not be fair, but I'm going to do it anyway. If you put 10 there, 10 squared is 100, and 100 times 2 would be 200. I'll write some intermediate steps here. Plus, by the way, this is order of operations, right? Aunt Sally, if you put 10 in there, 350 times 10 is 3,500. All right, so that's the left-hand side of the expression. And that would be revenue. Remember, the left hand is revenue. And then on the other side of it, we're putting 10 in. We're selling 10 vehicles. 10 squared, you do exponents before you multiply. 10 squared is 100 times 3. That'd be 300. These black markers aren't working great. I'm still looking for a good one. All right, maybe I found one. Plus, that's 300 plus 21 times 10 is 210, and then plus the 1,300. Okay, again, apologies for squeezing things in. I'm doing the best I can with what I have here. All right, so this side becomes 3,700, and this side crunches out to 1,810, I believe. All right, so it's mechanical arithmetic, and that's what I like about this. You don't have to memorize rules and patterns like some of the other approaches that I've seen, and some of the approaches I taught years ago that in my experience were disastrous. All right, but anyway, this is greater than, and we like that. We want revenue to be more than cost. So the point would be if we sell vehicles anywhere within that range, we're going to have a revenue that's greater than a cost, and that's what a profit is. So that's the point, mechanical arithmetic. Let's test a number bigger than 325. You can do whatever you want. I'm going to test 1,000. which again would be the idea, what are we gonna, what's our revenue and our cost if we sell 1,000 vehicles? Okay, so 1,000 squared is 1,000,000, and 1,000,000 times 2 is 2,000,000. I can already tell I'm gonna be out of room over here, and I'm kind of hitting the edge of the board, I'm sorry. Plus, I'll put that this way, 350 times 1,000, that's 350,000. Just remember, the left-hand number is revenue. Put the test number in. So if we sell 1,000 vehicles, our revenue is going to be this number. On the other side, 1,000, I'll put a question mark here in between these. 1,000 squared is 1,000,000, and 1,000,000 times 3 is 3,000,000. Plus 21 times 1,000, plus the 1,300. Sorry for the small writing. Not a lot of space here, folks. But anyway, this left-hand number comes out to be 2,350,000. Let me stop right there. If we sell 1,000 vehicles, our revenue is going to be 2,350,000. That's awesome. That's a lot of money that we brought in. But we got to see what it would cost us to generate that revenue. And you'll notice this number's bigger than that. Well, the revenue's less than the cost is what it's going to be. Because what is that? 3,000,000. It's so small. I'm so sorry. 3,022,300, I believe that is. But the point is this: the revenue is less than the cost when we sell vehicles in that area. And we don't want that. We don't want revenue to be less than cost. We want revenue to be more. We want more. All right? So, that's, hit pause, zoom in if you need to see those numbers better. I hope my arithmetic's right. But, so that would be the profit analysis. That would be a picture. Now, it's a word problem, so we're going to write up a word answer for this. Before we do that, just for pure practice, let's talk about how you would write this up using interval notation. I want to remind you intervals are from left to right. And so again, the leftmost number is 4, and excluded, right? Remember, equal is not in the thing, right? It's not a relationship we want. So a rounded parenthesis is the symbol for exclusion. So we're going to go from 4 on the left to 325 on the right. Same thing. 325 is a break-even point. Equal. That would be the mathematical way you would write that. The interval from 4 to 325. But the real world doesn't understand math symbols like we do. So again, on a word problem, let's interpret this for our boss. If they were to give us this question and ask us to give them an actual answer. So I typed up what I thought would be the reasonable way to express this answer, which will appear on the screen here momentarily, hopefully. Let's stop for a minute and think about it. All right, that's a pure math way of writing it. Now I want to talk about real life. How would you write this? Well, I would say that the first vehicle, we're selling vehicles, we're losing money. Once we sell that fourth one, we break even. Wouldn't the first profitable vehicle be the fifth one, right? And then we keep selling vehicles and we're still making a profit. But once we hit that 324th one, that would be the last one where we would make a profit. Then we're back to breaking even, and then we're back to losing money. I'm not an economist, but I think there's an idea, I remember 1,000,000 years ago at Emporia State University in Econ 101 or whatever, diminishing return. There's a point at which the cost will overrun the revenue if you reach a certain point. All right, now you can change these equations up here and change your business's situation, but if these are your revenue and cost equations, this is what we're dealing with. So as a sentence, I'm thinking, and again, look at the notes that were uploaded, I would say in order to make a profit, Cal has to sell anywhere from 5 to 324 vehicles. And that would be, if I were to give you a word question like this, and I did, please write up your answer using big people words like that, okay? So, I don't know, I did my best there. And again, when it comes to revenue and cost, don't we want revenue to be more than cost? So, we want revenue to be more. We want more. We want more. In this case, more.
Who thinks more is better than less? Okay, lie. more is better than less, because if stuff is not if there's more less stuff, then you might want to have some more, and your parents just don't let you because there's only a little.
Right.
We want more. We want more. Like, you really like it. You want more.
I follow you. It's not complicated. More is better. And AT&T has the nation's largest 4G network.
Yeah, when it comes to revenue cost, we want more. We want more. Thank you, young lady.